Hi there. This video will be all about custom scoring in scikit-learn. After all, in real life, you usually are doing something bespoke whenever you're doing something with machine learning, and that's where these custom scores can really make a difference. Before diving into this topic more deeply though, I figured it might be more helpful to also start with a tangible example, so let me explain the setup that I've got over here first. What I'm dealing with here is a dataset that revolves all around car prices. You can imagine that I've got colors of cars, different kinds of models. There's all sorts of different features that I have for these cars, but in the end, I'm interested in predicting the selling price. This dataset has some dirty data in it. There are some not available number values. There's also some string values for the selling price. So I'm doing a little bit of data cleaning over here. But after that, I am making my machine learning pipeline inside of scikit-learn, where I just have a pipeline that I'm creating. There is a one-hot encoder that I've configured over here. And then I'm following that up with a ridge regression model. This pipeline probably won't be state-of-the-art, that's not going to be the point, but it will be nice and lightweight, such that I can do this randomized grid search a bunch of times without incurring a big headache as far as compute goes. This ridge model over here has an alpha parameter that is a regularization term, and I'm using NP log space to just sample a few points for that hyperparameter. Then this random search will then do its thing. When I run fit, it is going to train itself, and it's going to basically do a hyperparameter search on my behalf. From here, what I'm also able to do is just explore some of these hyperparameters. You can see the hyperparameter alpha over here that I had configured. You can see that I'm trying out different values. And when I scroll to the right, you also see that I've got this mean test score. And this is actually just kind of an interesting phenomenon because an assumption is actually being made on your behalf here. After all, we didn't specify what score to actually go ahead and use, and effectively this randomized grid search is making an assumption on our behalf. Technically though, it's actually the ridge regression that is making the quote-unquote assumption. After all, under the hood there is a score method attached, and this score is effectively what is going to define the default score to be used. And you'll find one of these score methods attached to many estimators, and it's this score that this randomized grid search will actually use under the hood. It is just referring to something that is on the ridge regression over here. But if we wanted to, we could customize the scoring. So there's a scoring parameter, and we could fill that in. So maybe mean absolute error, that could be something I'm interested in. What I can then do is from scikit-learn, from the metrics submodule, I could import mean absolute error. And your first guess might be to take that mean squared error function and to just chug it into the scoring here, and that this might go ahead and work. I'm going to run it now, and you'll see that this actually breaks. So there we go. A bunch of red appears. Let's read the error message as well. And at the end over here, I can see that we get a value error. And it's a good error message, actually. It's complaining that it looks like we're receiving a metric function rather than a scorer. And there's a little subtle difference between the two. A metric function inside of scikit-learn is a function that takes your true labels and it compares them to the predicted ones. Depending on the metric, you might have some extra keyword arguments, but this is the default behavior of your metric function. You're really just trying to say something about your predictions. This is a metric function, but a scorer needs a different signature. Lucky for us though, there is a makeScorer function that can turn a metric function into a scorer on our behalf. And I figured it might be a good demo to use this and also to have a look at the signature that's changed. So, from the metrics submodule, there's a makeScorer that I can go ahead and grab. And what I can do is I can just pass the mean absolute error function to it. So, what comes out over here is a scorer, and we can actually inspect the new docstring that comes out as well. Just as a reminder, if we have a metric function, then the signature is that we start with the true y values and that we compare that to the predicted y values. But a scorer has different inputs. The first one is an estimator, and then it is followed up by the data that you would like to use to make a prediction, and then the prediction's true labels. I hope that you can appreciate that although the signatures of these two functions are different, it is hopefully clear that you can construct a score from a metric function like this. After all, inside of here, the main thing that you would have as an implementation is you would take your estimator you would use the predict method on it. This is going to give you your y predictions, so to say. And the only thing that you got to do is you got to return your metric function with your y true and your predicted labels. So from a metric function, we can construct a scorer. And the main reason why there's a distinction is that for a lot of cases, if you're doing something real quick manually, it's just kind of more useful to have a quick function like this metric. It's just that sometimes it also makes sense for implementation reasons to use a different signature. And the basic rule for scikit-learn is that inside of a grid search-like object, we really like to use scorers. Scorers are, in the end, just a little bit more flexible because you have access to the actual estimator as well as the raw data that goes into the estimator. But we still like to have our metrics around because they're just simpler to define and also work for a lot of other things. So if you ever find yourself in a situation where you have a metric that you would like to use for scoring, just remember that the makeScorer function is here to help you. But at the same time, why stop here? What we can also do is come up with our own metric function and again use this makeScorer over here to turn that into a proper scorer as well. So let's also do that. And here we are. I think this is kind of a nice example for this use case. The metric that I've come up with over here is called overshoot. And the whole thinking here is that maybe what I'm interested in is just measuring how often we really overshoot the price. If we overshoot by 1,000, maybe that's something we don't want. There could be good business reasons for this, by the way. It could also be the case that overshooting and undershooting have different business values, so counting how often we overshoot feels like maybe a good idea. Then, to actually use this metric as a scorer, you can see that I've got my scoring dictionary over here. You can see that I've got a name, and that I've also got the metric that follows. And the only thing I do extra is that I wrap the metric in this makeScorer function over here. By doing this, I can now look at my cross-validation results. You can still see that I've got lots of different alpha values over here. But you can now see that I've got my mean test and not score, but MAE, which corresponds to this name that I've attached for the mean absolute error. And if I were to scroll a little bit more to the right over here, you should also see the overshoot that is being mentioned. So that's now also something that's being logged appropriately. And I would argue this is great. Very often you want to have bespoke models, and for that you very often also want to have bespoke metrics to judge those bespoke models. And in business, it is always the case that you need to add something custom, is my experience. I've never had a business user come up to me and complain about the mean squared error, but I definitely have had business users tell me something about a monetary amount that is quantifiable that they would like to judge the model on instead. So, if you ever want to do that yourself, just know that in order to have custom scores, you basically just got to write a Python function. Just remember to wrap it around with this makeScorer.